Hello everyone, good evening. So we shall solve some more KCET questions of the previous. We'll solve some previous year KCET questions on the chapter alternating current. So the previous two parts that solved in question number 3. So in this third part of the video on alternating, I'll start from question 30. Any doubts if you have in these steps, then you please write that in the comments section. We shall clarify them in the subsequent videos. Any other chapter of physics, if you feel more difficulty, and also mention the name of that chapter in the comments. Some important questions for homework will be uploaded in the Sapience Education application. So please install our Sapience Education. It shall be helpful for your KCET exam. So here we shall start from question number 30. It's told that which of the following represents the variation of inductive reactance of the voltage. We know that the inductive reactance is known as omega is 2 pi into nu. So therefore, inductive reactance is directly proportional to the frequency, of course, frequency of the. So means that the graph will be a straight line passing through the origin. Graph will be a straight line passing through the. So option A is the correct one. And in question number 32, it is told that a 100-watt bulb connected to an AC source of 220 volt and 50 hertz. Then the current to the bulb is. You know that the power consumed or the average power consumed, that is equal to VRMS into IRMS cos phi. Now here cos phi will be 1 since phi here the power factor is 1 since why only the bulb is connected to the AC, only resistance. So VRMS is 220 volt. Frequency is 50 hertz. Therefore, I can say 100 watt, that is equal to VRMS, that is 20 to IRMS. Therefore, IRMS that will be equal to 100 by 220. 5 by 11. Option A. Then in question number 33, it is told the series LCR circuit, the power dissipation is through the resistance one. Since across the inductor and across the capacitor there is no power loss. The power loss happens only across the resistor. So option A is the correct answer. In LCR circuit, the power dissipation only across across the resistance. Question number 34 is told in Karnataka, normal domestic power supply AC is 220 volt 50 220 so 220 volt is the RMS value of voltage and 50 hertz is the frequency of. So it is RMS value of voltage and option B is the. Question number 35 called shape of transformer operates the 230 volt load current of 2 ratio of the primary secondary. So the ratio of the primary and the P by N is number of turns in the primary coil divided by the number of turns in the secondary coil, that is 20 given. And the current in the primary coil, that is now 230 volt is the voltage of the voltage across the primary coil, and this is the load current. Load current means it is the current in the secondary coil. Now therefore we know that the Vp by Vs, that will be equal to Np by S, that is equal to Is by I. Since Vs into Is, that is equal to Vp into Ip. Since the efficiency of the transformer is 1, it is an ideal. This is Vs into Is equal to Vp by Ip only. Then Ip that we have to find, Ip by Is will be equal to Ns by Np equal to 25 by 1. So Ip will be equal to 25 into Is is equal to 2 ampere. So it is 25 into 2, that is 50 ampere. So option B is the correct answer. The frequency of an alternating current is 50 hertz. What is the minimum time taken by the current to reach its peak value from RMS? Is the minimum time. So let's suppose current not sine omega t. So its RMS value, the RMS value of the current is I naught by that is reached at time. That will be equal to I naught sine omega t. So omega t1, omega t1 I can say. Omega t1, that is sine inverse of 1 by root 2, that is pi by 4. Therefore t1 will be how much? Pi by 4 into omega. Omega is 2 pi into pi, and pi will cancel, so this is 1 by 8 into 50, 1 by 400 seconds. So at this time the RMS value of the current is, and the peak value will be reached at not equal to I naught sine omega t2 suppose. Then omega t2, that is sine inverse pi by 2. T2 will be equal to pi by 2 into omega, which is 2 pi into So pi and pi will cancel. 1 by 4 into 4 pi is a T2 is 1 by 200 second, 2 by 400. Now therefore the minimum time taken by the current to reach its peak, therefore the minimum time required that will be equal to T2 minus T1 equal to 1 by 400 seconds. This we can write it as 1000 by 400 to 10 power minus 4 seconds. So this will be 2 to the 2.5 into 10 power minus 3. Option D is the correct one. Then number 37, it is told the readings of the ammeter and meter all circuit are received. Readings of the ammeter here, the ammeter. So here VL that is equal to VC means that I into XL that is equal to I into X is that I is equal to XC. That means omega equal to 1 by root LC. So it is a resonant circuit. It is a resonant here AC circuit. Resonant circuit. So therefore Z is equal to R. Since XL equal to XC. Therefore the power factor was 5. Therefore voltage plus this force that will be equal to square root of VR square plus VL minus VL minus VL whole square. C equal to VL. That's now it is equal to VL. Therefore, the RMS voltage across the source, that is 220 volt, that is only the voltage across the resistor. Therefore, the reading of the voltmeter is 220 volt. So this is the reading. And the current is the RMS value of the current that will be equal to VRMS by Z. VRMS is same as 220 volt by R, that is 100. 2.2. Option C is the correct answer. Question number 38, we can say that it's told an inductor of inductance L and R joined together in series. Inductor of R joined together in series connected by a source of frequency. The power dissipated in the circuit is by omega. the power dissipated in the circuit equal to VRMS cos IRMS. I can write IRMS, and VRMS is the voltage of this is V, and Z here, that is equal to square root of R square plus XL square. This is V into V by Z to cos phi, that is R by Z. That will be V square R by Z square. That will be R square plus. This is the average power that is dissipated in the circuit. Option D is the correct answer. And question number 39 is the power factor of circuit is 1. Power factor of RL circuit means it has resistor and the power factor, that is cos phi. If the inductive reactance, that is XL, that is 2, the value of the resistance, that is value of the resistance is how much? Cos phi is 1 by root 3. Okay, so then Z is equal to root 3 times R. Is also equal to square root of R square plus X. XL is 2. It is given as 2. Okay. Therefore, square both sides. 3R square. R square plus 2. 2 square, that is 4. 2R square is equal to 2R square, that is equal to R square equal to 2. R is equal to root. And D is the it is told in the given circuit. The resonant frequency that is mu, not resonant frequency, to 1 by 2 pi root over L. Since omega is equal to 2 pi nu, omega naught is equal to 1 by root LC, which is the angular frequency at resonance. Now root over L into C, that is root over L, 0.5 dN. Resistance C, that is 20 microfarad, that will be 20 into 10 power 6. This 0.5 milliamp, 0.5 into 10 minus 3. This we can write 0.5 into 10 power minus. No, it's not ampere. It's much Henry. 10 power minus 3 Henry into 20 into 10 power minus 6. Correct. So this will be equal to 0.5 into 20, that is 10. 10 into 10 power minus 3, that is 10 power minus 10 power minus 6. 10 power is equal to 10 power 8 square root of that. Therefore, the resonant frequency that is equal to 1 by 2 pi into 10 power minus. So this much such. So this will be 10 power 4 means this is 10,000 by 2 pi. So it is 5,000. 5,000 by pi. So it is 5,000 by 3.14. Approximately that will be 1592. That's option A is the correct answer. In question number 41 is told that the given circuit, the peak voltages across C, L and R are 30 volt, 11, 110 volt and 6. RMS value of the applied voltage. RMS value of the applied voltage RMS voltage across the plus square plus the RMS voltage across the inductor plus the voltage across capacitor. So these are the peak voltages which are being given. Therefore, the RMS value, these are the peak voltage. So here, so the RMS voltage across the capacitor, that will be RMS voltage across the, that is 10 by root 2. RMS voltage across the resistor is equal to 60 by root 2. Therefore, the RMS voltage across RMS value of applied voltage, that is equal to square root of this will be the square root of VR square, so 3 by root 2 whole square, VL, that is 110 by root 2. So 110 root 2 minus 30 by root 2 whole square. So this will be root over 3 square by 2 plus this is 80 square by 2. I can take 1 by root 2 as common outside. We root over 60 square plus 80 square, which is 100 by root 2 volts. So this is the RMS value of the applied. Therefore, V, that will be equal to 100 by root 2, 50 into root 2. 100 by root 2, so 50 into root 2 volts. Root 2 means it is 100 into root 2 by 2. 100 into root 2 by 2, which is root 2 means root 2 is 1.414, 141.4 right? 7s are 14, 7s are 14. That is 70.7 volt. Option A is the correct answer. Question number 42, it is will be the reading voltmeter and it shown. Here one resistance 45 ohm. There we have an AC voltage source. RMS voltage as 90 volts. Here we have an meter. Here we have a capacitor. Capacitance whose capacitive reactance is 4 ohm. Here one factor is also reactive reactance, that is the reading in the voltmeter and the ammeter, that is this current I is the RMS value of the current that is going to suppose. Here actually it is a series RLC circuit only, but we have to find the voltage across the inductor and the capacitor. We have to find the net voltage across inductor and capacitor. We have to find the current also. Therefore here XL, that is equal to XC. Resonant circuit. That is the resonant circuit. The resonant AC circuit. So therefore Z, that is equal to R. The net impedance is equal to the resistance 45 ohm. Therefore the current in the AC circuit is equal to RMS voltage divided by Z. 2 amp. So the reading of the ammeter is 2 ampere. And the net voltage is equal to the net voltage across the voltage of RMS voltage of the source is equal to the RMS voltage across the resistor, since it is a resonant. The net voltage across the inductor and capacitor, that the reading of voltmeter is 0. Option B is the correct. 43 is told that LC oscillations are similar and analogous to the mechanical oscillations of a block attached to a spring. The electrical equivalent of the force constant of the spring is. So in the case of LC oscillations, the frequency, that is the angular frequency of the SHM, is given as theta is 1 by root of LC. In case of a springless system, mass, so here kx equal to the force, that is equal to mf. Acceleration is minus k by m into x. So this is omega square. Omega square is k by m. Omega is root over k by m. Here the spring constant now for the LC oscillations we can write this as square root of 1 by c by l. So if we compare the equivalent of the mass, the spring, that is equal to the inductance, and the spring constant k, that is equivalent to the reciprocal of the capacitor. If we compare the electrical equivalent of the force constant is 1 by c. It is the reciprocal of the capacitor. The reciprocal of the capacitor. Reciprocal of capacitor. C is the question number 44. So that in an oscillating LC circuit, L is equal to oscillating LC circuit, the inductance L is equal to 3 millihenry and the capacitance therefore capacitance C, that is equal to 2.7 microfarad. Equal to 0, the charge on the capacitor is equal to 0, the charge Q on the capacitor 0, and the current I is equal to 2 ampere. The maximum charge that will appear on the will be. So this is the peak current, that is. Therefore, in the LC oscillations, we know that the sum of the magnetic energy stored in the inductor, magnetic energy stored in the electrostatic energy stored in the capacitor, that is always so I can say that the magnetic energy stored, the maximum magnetic energy stored in the inductor, that is equal to the maximum electrostatic energy stored in the capacitor. The maximum electrical energy, maximum magnetic energy stored in the inductor, that will be half Li naught square. That will be equal to the maximum electrostatic energy, that is half into C V naught, or I can say Q square by Q naught square by 2. 2 and 2 will get cancelled. So Q naught square, that is equal to LC into I naught square. Therefore Q naught is the maximum charge that will appear on the capacitor, that is equal to I naught into root over. So the maximum current in the inductor is 2 ampere, so 2 ampere into root over L, that is equal to 3 millihenry, which is 3 into 10 power minus 3 into 10 power minus 3 into the capacitance, that is 2.7 into 10 power minus 6, will be 2 into the root of 3 into 2.7, that is 8.1 10 power minus, or I can say 81, 2 into square root of 0.4. I can write this is 81 into 10 power minus 4. It will be 2 into 9 into 10 power 18 by 18 into 10 power minus 6, so this is 0.18 coulomb. This is 10 power minus 3. This is 10 power minus 9. 10 power minus 10. 10 power minus 5. 18 into 10 power minus 5. 1.8 into 10 power. Or you can say 18 into 10 power minus 5. 10 power minus 5. And B is the correct. Question number 45, it is told alternating current is given by I is equal to I1 sin omega t plus I2 cos omega t. RMS current is given by RMS current is given alternating current is given by we can write this as I is equal to the square root of I1 square plus I2 square sin omega t plus alpha, where tan alpha it is I2 by I1. So alpha is tan inverse of I2 by I1. Now therefore the mean squared value of sin omega t plus alpha is half. So therefore IRMS, root mean square value of the current, that will be equal to I1 square root of I1 square plus I2 square into root mean square value of this. So this square root of 1 by 2. So what is square root of I1 square plus I2 square. So option A is the correct answer. Question number 46, it is told that fully charged capacitor C with initial charge Q connected to a fully charged capacitor with initial charge Q0 connected to a coil of self-inductance L T equal to the time at which the energy is stored equally between the electricity and the magnetic field. Time at which the energy is stored equally in between electricity and magnetic field. So the when so the initial amount of energy, the initial energy stored in the capacitor, the initial energy stored in the capacitor, that is Q0 square by 2C. When the energy is stored equally in between the electricity and the magnetic field, so it means that half of this energy at time t equal to 0, at time t is equal to suppose t1, the final energy stored in the capacitor will be half of this energy. Since why? Since the energy stored in the magnetic field, since the magnetic energy stored in the inductor, that should be equal to the electrical energy stored in the static energy stored in the capacitor. This Q0 square by 4C. So the final charge here, the charge in the capacitor will be given as Q0 cos omega t. The current in the inductor, that will be equal to I0 sin. Therefore, U final, that is equal to Q square by 2C, that will be equal to Q0 square by 4C. Means that Q will be equal to Q0 by root 2. Therefore, Q0 by root 2 will be equal to, so it means Q0 by root 2 should be the charge stored in the capacitor at that time at which the energy is equally stored in the electricity and the Q0 by root 2, it is equal to Q0 into cos omega t. So Q0 will cancel out. Cos omega t is equal to 1 by root 2. So therefore, omega t is equal to cos inverse of 1 by root 2, that is pi by 4. So therefore, t will be equal to pi by 4 into omega. So that will be equal to pi by 4 into 2 pi. And the frequency omega, that is equal to 1 by root LC. Omega, that is 1 by root LC. There is pi root LC by 4. Option C is the correct answer. Then question number 47, told a series resonant AC circuit contains a capacitor and an inductor. So the inductance is 10 power minus 4 Henry and capacitance is 10 power minus 6 farad. The frequency of the electrical oscillation. So the frequency omega, that is 1 by root over LC. equal to 1 by root over 10 power minus 4, 10 power minus. So this will be the angular frequency, but we have to find the frequency that is new, that is equal to 1 by 2 pi root LC. Omega is equal to 2 pi into nu. 2 pi root over LC. So it is 1 by 2 pi into root over 10 power minus 10. That is 1 by 2 pi into 10 power minus 5. It will be 10 power 5 by 2 pi hertz. A is the correct answer. Then we shall solve the last question in this chapter. Question number 48, it is shown that in a series LCR circuit, the resistance is 300 ohm and the inductance of the inductor is 2.9 Henry. The capacitance of the capacitor is 2 micro and is connected to an AC voltage source whose angular frequency is 1000 10 power 3 radian per second. Then the impedance Z of this circuit will be, so Z will be equal to square root of R square plus C minus X L square. C is the capacitive reactance, X is the inductive reactance. So Xc is equal to omega into L. That will be 10 power 3 into 0.9, which is equal to 900 ohm. Resistance is 300 ohm. XL, that is the inductive reactance, and Xc, that is capacitive reactance, that is 1 by omega C. 1 by omega, that is 10 power 3 into 10 power 6, 2 into 10 power minus 6. So this will be equal to 1 by 2 into 10 power minus 3. 10 power 3 by 2. 1000 by 2. 500 ohm. Therefore, the net impedance of this circuit, that is equal to square root of 300 square plus Xc, that is 500 minus 900 plus 500 minus 900 whole square. So this much ohm. This is square root of 300 square plus 400 square ohm. It is equal to 500 ohm. So option A is the correct answer. Hope all of you have understood the solutions of these 48 questions. Any question, if you have doubts, then please write us in the comments. About Sapience education, we shall upload important questions previous KCET. Thank you everyone.